So the question here is saying we should express Q. We should express Q over 1 minus 9y squared in partial fractions. So what we are going to do is firstly we factor the denominator. We factor the denominator So to factor the denominator is to recognize that it's difference of 2 squared. So we say 1 minus 9y squared is equivalent to 1 minus 3y, then 1 plus 3y. That's difference of 2 squares. Then we are going to assume that Q over 1 minus 9y squared is equivalent to A over 1 minus 1 plus 3y plus B over 1 minus 3y. Then we will multiply 3 with this. We are going to multiply with this bracket here, so that we get Q is equivalent to A open bracket 1 minus 3y, then plus B open bracket 1 plus 3y. Alright, that's fine. Then the next thing is to expand. So we're going just to expand, to put in A, put in B here. We get expand. So to expand, I'll get Q is equivalent to A minus 3AY, A minus 3AY plus B plus 3BY. Alright, then I'll group the constant terms together. I've got A and B. So actually what I'll simply do is to say A plus B is equal to 2. To equate the constant terms together. Then it's to say Q is equivalent to A plus B. Okay, that's the constant terms together. Then terms in X, I've got minus 3A, terms in Y rather, minus 3A and plus 3B. So it's equivalent to 0 because I don't have a term in Y this side. So I'm going to say minus 3A plus 3B is equivalent to 0. So this is equation number 1. Then this one is equation number 2. Okay. So the next thing that happens is I will from the second equation, I'll see that if I say minus 3A then minus 3B here, I'll actually, or rather, minus 3A minus 3B here, it's actually going to give me, suppose that maybe I factor out 3, or rather I can take AB side to get 3B is equivalent to 3A, because I take minus 3 this side, then I'll divide by 3, so A is equivalent to B. So if A is equivalent to B, it actually means that if I would take this A to put it in equation number 1, I'll get A plus A A plus A plus A is equivalent to 2. Okay, I guess A plus A is equivalent to 2. Therefore, 2A is equivalent to 2, so A is equal to 1. Then B, for B now, I can say 2 is equivalent to A plus B, which is equation number 1. Equation number 1. So my A now is equivalent to 1, so 2 is equivalent to 1 plus B. I can take 1 this side. B is also equivalent to 1. So to express it in partial fractions, I'm saying 2 over 1 minus 9y squared is now equivalent to, I'll take my value for A and B. So A over A, which is 1, over 1 plus 3y, and plus 1 over 1 minus 3y. So I've expressed this one here, in partial fractions here. Alright, so part B is saying that the variables x and y, they satisfy the differential equation, this one here. And when y is equal to 0, x is equal to 1 over 12 pi, I should solve the differential equation to obtain an expression for y in terms of x. So I'm going to solve the differential equation. So maybe just to repeat it again, 2 cos squared 3x dy dx is equivalent to 1 minus 9y squared. So to separate the variables, I'm going to have dy over 1 minus 9y squared is equivalent to dx over 2 cos squared 3x. Okay, so what I need to do is to integrate both sides. But before I integrate both sides, so I actually need to integrate after separating the variables. So I should recognize that this expression here, 1 over 1 minus 9y squared, from the partial fractions that I got, it's actually equivalent to 1/2 of because actually the it's actually equivalent to rather 1/2 of it's actually equivalent to 1/2 of 1 over 1 plus 3y plus 1 over 1 minus 3y. Okay. Because the 2 which was here, I divided it to take it this side. So the integral of dy over 1 minus 9y squared, if I integrate it, I'll get 1 over 6 ln of 1 plus 3y over 1 minus 3y. That's the integral of this after doing logarithmic integration here. I'll get this expression. Then I'll use some more space that I'm given. Alright, so then the integral of the other side, integral of the x over 2 cos squared 3x is actually equivalent to half of integral of sec squared 3x dx. Alright, which is equivalent to, if I integrate, I'll get this equivalent to 1 over 6 tan 3x. Okay, so that's what I get. Now to combine the results from the left hand side and the right hand side, I'll get 1 over 6 ln of 1 plus 3y over 1 minus 3y is equivalent to 1 over 6 tan 3x. Okay, that's combining the both sides. If I multiply by 6 to eliminate 6 both sides, multiply by 6. Okay, if I multiply by 6, I'm going to get ln of 1 plus 3y over 1 minus 3y, then equivalent to tan of 3x plus c. That's what I get. So this is the final expression. Actually, I need to use the initial condition so that I can find the value of c. So I'll use the initial conditions. Use initial conditions. Okay. So to use the initial conditions, I'm simply going to recognize that our question, it had told us that y is equivalent to 0 and x is equivalent to 1 over 4 pi. Y is equivalent to 0, x is equivalent to 1 over 4 pi. Okay, so the next thing is I would make a substitution. So for tan 3x will be equivalent to tan 3 open bracket 1 over 4 pi, which is equivalent to tan pi over 4 which is equivalent to 1. If you punch in the calculator, you're going to get 1. So then the other side saying ln of 1 plus 3, substitute 0 for y, then 1 minus 3, substitute 0 for y, then I'm going to get ln 1, and ln 1 is equivalent to 0. Ln 1 is equivalent to 0, which is equivalent to 0. So what I do next here is to equate now the left hand side and the right hand side. So, or rather, to take it back into the equation, whereby I'll get ln 1 is equivalent to 1 plus c, because I want to look for the constant. Ln 1 is 0 now. It's equivalent to 1 plus c, which gives me c being equivalent to minus 1. So the final expression now, final expression ln, I'm now taking back the constant in the first equation, 1 plus 3y over 1 minus 3y. Then it will give me tan 3x minus 1, because I now have my constant c as negative 1, like this one here. Okay, so this is final expression. But then the question was saying that I should express y in terms of x. So to express y in terms of x, I'll introduce exponent so that I will remove the ln here. So it will become 1 plus 3y over 1 minus 3y is equivalent to exponent of tan 3x minus 1. Okay, so the tan 3x minus 1 like that. So to solve for y, because I'm supposed to leave my expression in terms of y, I'll get y is equivalent to exponent of tan 3x minus 1 minus 1 here over exponent over 3 open bracket exponent of tan 3x minus 1, because exponent of tan 3x minus 1, then plus 1 down here. Now close it. So maybe to further break it down and how I come up from here up to here, maybe it needs some further explanation, but then to someone who knows how to go about it, there won't be much